Hello, welcome everybody. I'd like to welcome to the journalists and our audience who joined us online via Zoom. My name is Eva Marie Socha, and I am the Communications Director for the Purdue Applied Research Institute. I'd like to thank you for joining us for this media conference via Zoom on the opening of the Purdue Hypersonics and Applied Research Facility. The official opening is tomorrow. We are having this media event today because some of our panelists are going to be involved with events tomorrow. So the way we would like to begin this, I'll introduce our panel to you and then open it up for questions following the panel. We are recording this, and we will make the recording available to any journalist who asks. You are also available, also welcome to record this for your use. Each reporter will get a question and a follow following the presentations. I do ask that you mute your mics when you are not speaking, and of course, this is on the record. So I'd like to go ahead and begin by introducing our panel. First, we have Mark Lewis, who is the Chief Executive Officer of the Purdue Applied Research Institute. We have Dan Golden, who is the former NASA administrator. He is founder of Cold Canyon and also an entrepreneur and technologist. We have Marty Hunt, who is Vice President of Hypersonics and Advanced Materials at Dynetic Technical Solutions. And Josh Stoltz, who is Senior Director of Advanced Programs for Stratolaunch. Again, thank you for being here. If you still are in need of a media kit, just send me an email after the conference and I'll be happy to get that to you. So let's go ahead and begin with Mark, if you would please go ahead and start us off.
Sure. Well, Eva Marie, thank you so much, and thank you to the audience. So tomorrow is going to be an incredibly exciting day. I would argue not just for Purdue, but for the nation, because we're going to be dedicating a new facility, as Eva Marie said, the HARF facility. It's a 65,000 square foot facility with several state-of-the-art wind tunnels. But it's even more than that. It's an investment in test and evaluation and also research capabilities that this country desperately needs. For those of you who know me, know that I've spent most of my career in the hypersonics arena. And I believe very much that we are in a race. We are a race with peer competitors who are determined to beat us in hypersonics. And in at least two cases, Russia and China, they have already deployed hypersonic systems. The Russians have even used hypersonic systems in Ukraine. Fortunately, they don't work very well, but it says more about what the Russians do than the technology. We are in a race, whether or not we choose to acknowledge it or not. And there are several keys to winning that race. One is, of course, making sure we've got the best and the brightest, the best minds working in hypersonics. But it's more than that. It's having the workforce that can support our government and industry needs and partners. It's having the facilities where we can do the tests that will allow us to understand the physics and develop the technologies that then will roll into the capabilities that are produced by industry. It's an honor to be on this stage with my colleagues. Dan Golden, who I always say needs no introduction, truly needs no introduction. Marty, thank you for joining us as well. The support from Leidos has been phenomenal. Josh, thank you as well. Stratolaunch has made a tremendous investment in the Indiana hypersonics ecosystem. You had a leadership position in government, and delighted to be partnering with all of you.
Great, thank you. Dan?
I am delighted to be here. I'll speak to another part. That's a lot better. Okay. I spent the day with Mark and a number of others touring some of the facilities. It feels like the 1960s all over again. The spirit. You talked about the facilities, Mark. But I had a chance to meet some of the brilliant young people here. But more than that, in these early facility tours today before the official one tomorrow, I got to see something that didn't exist in the 60s, and that is comprehensive test facilities for all aspects of hypersonics, from materials to computing to testing and to reusable vehicles that are going to be another validation so that we will not only be able to build better hypersonic vehicles, but we'll do it much faster for much less money because of the integration of all these functions I saw. But it is the people, the professors, the students. I had a chance to talk to a PhD student working on a rotary detonation engine. A lot of words. It probably will be an important factor in the future to go with the wind tunnels in the flight. So it's this sense of self-confidence and brilliance is what I got today. And I hope to see more of it tomorrow.
Oh, thank you. Thank you for being here. Marty?
Okay, thank you. Yes, to echo some of the comments that have already been made by Mark and Dan, with hypersonics being one of the nation's top priorities, it necessitates a growth trajectory for us. With the HARF, that establishes just that point. It enables the workforce, our future workforce, to develop its knowledge base with students working with researchers, and then over time, them transitioning out to industry and bringing that knowledge base out. Because with the growth of hypersonics, we need a larger hypersonics technology base in the industry side. The other aspect of this is the testing capabilities of being able to move fast. With the HARF, it's expanding that ability so that not only with research, but with industry, we're able to rapidly get results, physical results for testing that's being conducted that helps us propel our programs, not only in the prototype phase, but also in the program of record phase into the future.
Well, thank you for the kind introduction. Very, very honored to be here with these gentlemen here on stage. Really looking forward to the grand opening tomorrow. Purdue has been known for many years as a center of excellence, a world-class research facility, certainly for a wide variety of reasons because of my past life that Mark mentioned, working hypersonics in both the Air Force and at DARPA. We knew Steve Schneider well and his Mach 6 quiet tunnel. It's great to see the Mach numbers increasing, the size of the tunnels increasing, and then new capabilities coming online here in Indiana. So Stratolaunch is excited to be a partner with Purdue. We have our advanced programs office here in West Lafayette, and we're excited for the partnership for a couple of reasons. Mark mentioned the race, the potential arms race with our strategic competitors. What's important in a race is going fast. And that's not just flying high, far, and fast, which at Stratolaunch we like to do. It's developing those systems quickly. And that only happens when you have a synergistic combination of design tools, ground test facilities, conceptual design capability, and then flight test validation. And so here at Purdue, we're able to find that synergy, build on the strong basis of ground test facilities that are being invested here in Indiana, and then go build and fly the aircraft. Thanks.
Great, thank you. Thank you all for your comments. I'm going to go ahead and open this up to the reporters online right now. I'm just going to go down the list as I see you on Zoom. And I'd like to go ahead and start with Steve Trimble from Aviation Week. Steve, if you would go ahead and unmute your mic.
Yeah, thank you. Can you hear me?
Yes, we can.
Great. And thank you for doing this. Congratulations on the facility. I appreciated that Josh Stoltz mentioned this, the competitive aspect of this. And I don't know if you saw over the weekend, but the Institute of Mechanics at the Chinese Academy of Sciences announced that they completed development of the JF-22 hypersonic wind tunnel and have started using it. That's in addition, of course, to FD-21 and JF-12. And can you talk about how, first of all, just what your thoughts are about that JF-22 and the capabilities the Chinese have relative to ours? And then second, what these facilities at the HARF bring to the U.S. infrastructure, particularly the high pulse tunnel that's moving over from Ronkonkoma.
Okay, so happy to talk about that one. So, I haven't seen that Chinese facility, though I'd love to. So if any of our Chinese friends are listening, happy to take that invite. So I won't talk in any detail about that. But, high pulse and the quiet Mach 8 that are going in here are important. High pulse was a very important facility back in the day when Gassel ran it. And I expect that will continue here at Purdue. And one thing that I think is incredibly important, but that often doesn't get a lot of press coverage, we often see pictures of the big pipes that push the hot air, and those are important parts of the facility. But the really important thing that Purdue is investing in here are the high fidelity diagnostics that the researchers here at Purdue will be able to use to get unprecedented insights into hypersonics flow. We may have been able to push hot air fast for a lot of decades, but the kind of modern diagnostics that these researchers are developing haven't existed before, and there are new insights to be gained from that work. So great to see that kind of work being done in a modern test facility, and excited to be part of it here at Purdue.
Please.
Add to that. And the key here is one of synergism. If you look at it in the big picture, what we're trying to do in America is bring together academia, industry, government in multiple domains, in test, diagnostics, but not just test on the ground. The beauty, Josh, is your being here with Stratolaunch with a reusable launch vehicle. So having the capacity to generate the computational fluid dynamics analytical tools, test it on the ground, then test it in space, because you can't get perfect simulation of what's on the ground. But when you go to space, you get the real conditions, but you don't have the same diagnostics. So it's the integration of these three things. But as I opened up, I was very heartened to see how a university makes such large investments in the capital plant and then partners directly with industry. This is the exciting part. And I'm not sure, I know there was an issue about China. This is unique. I've been around more than anyone on this stage. I've been to China, I've been to Russia, I've seen it. We in America sometimes see things that other countries say, and we need to focus on what we're doing here. What they do there is fine. What's going on here at Purdue with this incredible investment and reach out in partnership is what America does the best. So I think this is great.
Okay, if I jump in.
Please.
First, Steve, great to hear from you, and thanks for joining us. Always a pleasure. I agree with everything that Dan and Josh just said. I will point out, when I look at programs, and especially in China, I have to tip my hat and say, well, they're making long-term investments. They're building facilities, they're investing in universities, and that's how we know they're serious. That's how we knew originally that they were serious, and that's how we know we're serious too. The fact that we're investing, as Dan just said, that we're investing in these facilities, that we're building these connections between academia and industry, that we're investing in the future workforce, students, undergraduates, graduate students at all levels. That's the mark in the sand that says we're serious about hypersonics as well.
All right.
Just to add on to that, when the student base, when they're looking at the significant investments being made, as well as the technology growth that's coming in with the HARF, it gives them a trajectory for their career. So they see that hypersonics does have a future. So that builds the emotion, that gets the entrepreneurship running, also the collaboration between industry and academia.
Thank you. Thank you. Very great question. Thank you, Steve. I'd like to go next to Ben Wolfgang from Washington Times. Ben, would you please unmute your mic?
Hi there. Can you all hear me?
Yes, we can.
All right, great. Thank you. Mr. Lewis, I think you said during your introductory remarks, you mentioned Russia deploying hypersonic weapons in Ukraine, and perhaps them not working as well as Russia had hoped. Can you expand on that a little bit and talk about if there are any lessons that we all can or should draw from how hypersonic weapons have worked or not worked so far in the Russia-Ukraine conflict? Are there any broad lessons we can take away from that, or is that just isolated and perhaps the failures of its program specifically?
I think the best message I can draw is the Russians build really crappy weapons. let me leave it at that. I've heard people say, "Oh, does that mean that hypersonics doesn't work as effectively as you've been saying?" That no, it doesn't mean that at all. It just means that the Russian systems are very limited, and a lot of what the Russians have been saying has been overinflated, shall we say? But that should not. We absolutely should not look at the performance of their systems and try to draw any analogies to our systems.
Okay. Thank you.
Okay. Thank you, Ben. I'd like to go next to Courtney Albon from Defense News, C4ISRnet. Courtney, if you'd unmute your mic.
Hi, yes. Thanks for taking my question. This might be a little repetitive, but I wondered if you could speak to the implications of this new facility for DoD, given particularly their hypersonic testing infrastructure needs and some of the shortfalls there. And then also, how will you kind of partner with the department for them to be able to take advantage of this facility?
I'll take a shot at that because I've been through the facilities twice now. The leadership of Purdue and Mark and industry and the DoD have already talked. These facilities are designed directly for cooperative work with all aspects of the U.S. government, and not forgetting about it, because it's not just the hypersonic flight. These systems are important to the national security of America. So I really have to tip my hat to the leadership of Purdue and industry in working together with the Department of Defense in such a cooperative fashion that they can do the important work with the appropriate arrangements to protect it. So this is a really unique feature for a university and something that we ought to be really proud of. Sometimes we Americans keep criticizing ourselves so much. This is an unbelievable partnership, which is the strength of who we are. And I think it's going to yield tremendous results.
Thank you.
Courtney, good to hear from you as well. Forgive if I can jump in. So I am the newcomer at Purdue. I'm actually 3 weeks on the job as the CEO of the Purdue Applied Research Institute. And very candidly, one of the things that attracted me to this position is the incredible commitment that Purdue University as a whole has in support of national security. And you see it at the very top. I mean, President Mach is all about supporting national defense. You see it among the faculty. I mean, there are faculty members here who work hand in glove with their counterparts and their colleagues in government and also in industry. And it's a beautiful relationship. DARPA activities, AFRL activities, they're infused throughout what Purdue is doing. At the same time, Purdue is very focused on what are the real needs of the government. What are the important problems that need to be solved? You see that in the advanced manufacturing facility, the development of the quiet tunnel. These are critical needs in the field, and I think Purdue has been appropriately responsive.
Great. Thank you, Courtney. I'd like to go next to journalist Dave Bangert. Dave, if you'd unmute your mic, please.
Sure. Thanks for taking the question. Following up on that, there have been questions about why is this Purdue's job to do this? Why not the federal government taking this role in defense? Is there an answer to that? Why is it taking Purdue, and should universities be taking the lead in this job?
I'd be delighted to answer. It's an excellent question. And being the most mature here, I've seen quite a bit. American universities used to be very close with national security. They were part of the efforts in World War II, in the Korean War, and the wheels came off the tracks during the Vietnam War. And there seemed to be a sense that defense and national security needed to be in a separate place from the universities. But the leadership at this university and the leadership in the Department of Defense and the whole national security community understands we'll never have the workforce to undertake the critical needs of America in protecting the citizens. And that's the exciting thing there's this tremendous pride that people understand. They're not just working on science, they're working on projects that's going to help let people sleep well at night, because America has a long way to go forward. So I don't think universities should be apologetic for working with national security. I'm thrilled, and there are other universities too that are doing it. There's a new tide, a new sense in America about coming together as Americans to take on the terrible challenges that this country has.
One thing that I've seen work effectively along those lines is the concept of badgeless work environments, where you have government, you have industry, universities, research groups working badgelessly in the technology environment for hypersonics and sharing the ideas, so that you have the collaboration that in the previous years really has not happened to the level of that it's occurring now. So just wanted to add that anecdote on.
Thank you. Thank you. Thank you, Dave. I'd like to go next to journalist Katya Gorsuch. I hope I pronounced your name correctly. If you would please unmute your mic.
Hi there, and thank you for taking my question. What I was wondering is to what extent will students be involved with this research exactly?
Yeah, I'll take that one. So in almost every step of the way. Again, universities aren't just places that present knowledge to students, they're places that create new knowledge. And students are essential to that. And one of the things that you see here at Purdue is not just master's students, not just PhD students, but undergraduate students, beginning steps of their engineering curriculum. They're involved in the research, and undergraduate students are involved directly and will be involved directly into the activities that are undertaken in the HARF.
Mm-hmm. Yeah, I'd just like to add, one of the things Stratolaunch is really excited about is student involvement at all levels, and believe it or not, that starts at undergrad. And so we're already talking to some professors about some of their promising undergraduates with interesting design ideas, and we'll see how those might pan out for products that we're looking at. And of course, those undergrad projects have to be fairly tightly tailored so that they fit. And then we're also really excited about the graduate level research and bordering on production level research that you can do with the kind of facilities that Purdue is investing in now.
Thank you. Thank you, Katya. I'd like to go next to Laura Heckman from National Defense Magazine. Laura, if you'd please unmute your mic.
Hi, I actually don't have a specific question. Thank you.
Okay, thank you, Laura. I'll go next to Marcus Weisgerber from Defense One. Marcus? Marcus, do I still have you? If you'd unmute your mic. Okay, we'll come back to Marcus. If we could go next to Meredith Roten from Janes. Meredith, could you unmute your mic, please? Why can't I say this today?
Hi, thank you so much for doing this. I wanted to ask about the high pulse in specific. I know it was donated from Northrop Grumman, and it's seen a lot of tests and had a lot of experience. Can you speak to how transferring this from Ronkonkoma, how that was modernized during the system was modernized during that process, and how that speaks to the progress made in hypersonic testing at Purdue?
Sure. So let me take that one. Meredith, great to hear from you again as well. So HyPulse is, as you allude to, has had a long and distinguished experience. Installed, as you mentioned, at Ronkonkoma, operated by Gazel, out on Long Island. For various reasons, the Northrop Grumman no longer saw a need for it at Ronkonkoma, but it's still an extraordinarily viable facility. So they very graciously donated it to Purdue, and that became the centerpiece for the HARF facility. So essentially, the tunnel was dismantled. It was shipped a third of the way across the country, reassembled in this new facility. And that's most of the hardware, including the drive sections, the tubes that I think we talked about a little bit earlier. But what's new in the facility is all the instrumentation. So it's going to be completely modernized with instrumentation, completely modernized in capabilities. HyPulse is still a world-class facility in that it can reproduce conditions, Mach 25 and beyond. It produces really nice gas conditions for simulating the hypersonic flight corridor. So HyPulse is still very much a relevant facility, and with its upgraded instrumentation, we see it having applications for years, maybe decades to come.
Before we take the next question,
Sure.
I want to comment on the broader issue. And there's one other item that I think is very important. Now that I'm more mature, I no longer do the big noble things. But what I'm doing now is I advise Cerberus Capital Management. I have my own firm, and I interact with a lot of young people. And over the course of the last couple of years, I've engaged with a number of students and professors from Purdue. Oh. And they are not just coming here to learn, but they're starting businesses. In the bleeding edge of hypersonics. And in fact, today we were on a tour going through some of the propulsion, which is not part of tomorrow, but it's part of the essence of America's taking a leadership role in hypersonics. There were two professors starting companies, and there was a brilliant young lady. It's so we are building the next workforce, but the next workforce is different than the workforce I was trained for, because I was trained in university. I then went to work for NASA, then I went to a corporation. These young people are so far ahead of the technologies with the facilities, the computational capability, the diagnostics here, that they're ready to go out and start companies that then feed into the big companies with the innovation. This is what's different. And when universities lay down $70 million to build facilities, it then gets equivalent investments by industry and government. So you get a synergism that doesn't necessarily take place in other countries. And it makes me feel good to be an American, to be on this campus, to see this, and to work with these young people. They're terrific.
Thank you. Thank you, Meredith. I'd like to go next to Sydney Duffinas from WFYI. Sydney, if you'd please unmute your mic. Do we have Sydney with us? No? Okay. Can we try Marcus Weisgerber again from Defense One? Marcus? I'm not getting a response from Marcus either. Okay. I do believe that is the end of our questions. I'm sorry? Oh, absolutely, yes. If there is anybody or are any journalists online who would like to have a follow-up question, we welcome them now. Oh, you just unmute your mic.
This is Meredith Roden from Janes. I wanted to ask about this year and the kind of year that hypersonics have had with seeing some delays in the long-range hypersonic weapon and also one of the Air Force's programs having some challenges. And I was wondering if you could speak to how you envision Purdue's role in the path forward of, supporting, overcoming those challenges from your role and supporting the DoD in that.
So from a Stratolaunch perspective, we want, I mentioned going fast in my initial comments, and that's not just flying high, far, and fast. That's getting to those test events quickly with our new designs. Part of our initial engagement with Purdue is actually working on design tools to turn those designs faster so that we get through those preliminaries, so that we build the confidence in the ground test facilities and the simulations so that when we do get to those flight events, they count. And we're able to bring home those terabytes of data that our customers want. So that's the role. It's the, when we're successful, you probably saw our press releases about a successful safe separation off of our Rock aircraft of our Talon A hypersonic rocket plane just a couple weeks ago in May. And we'll certainly let you know when we're successful going hypersonic. Hopefully fall and then through the end of the calendar year for an actual reusable flight for our systems. But getting to that test range quickly and having that, those press releases are the tip of the iceberg. And the rest of the iceberg is all the work that you do beforehand, before you get that range time to go fly fast. And so that's where we really see the value of a university partnership, is building the rest of that iceberg that's below water level that provides you a firm foundation. Thanks.
So Meredith, if I could jump in on your question, because it's a very well posed question. So what we have seen in some recent failures is hypersonic systems that are failing, not because of the hypersonics technology, but because of incidental issues, other issues, support issues, and it's very frustrating. We have to be allowed to fail. We have to allow our programs to fail. We have to allow our program managers to fail. We have to be willing to take risk, or else we won't push the envelope. But having said that, we have to fail for the right reasons, right? In my opinion, there are noble failures, and then there are dumb failures. The noble failures are when your system fails because you didn't understand the physics, because there was just a question that you didn't answer before you implemented the solutions, and it just didn't work. And then there are the bad failures, the dumb failures. The fin falls off, the wire's broken, you didn't read a checklist properly, things like that are just so incredibly frustrating. One of the reasons that having test and evaluation facilities, such as those in the heart, is so important is it addresses that first set. Right? It allows you to learn more about the physics, understand the engineering, so that you get a better handle on that first set. So frankly, you're buying down risk. You're never going to eliminate risk entirely, but you're buying down risk. And that's an important thing, an important element of what something like HARF brings to bear. Now, how do you eliminate that second source, frankly, the dumb failures? One major ingredient to that is doing it often enough. Right? Why have we been having failures like that? Because we haven't been testing. We haven't been testing often enough. We're doing it once every couple of weeks, once every couple of months. We need to get into a rhythm where we're testing, flight testing constantly, putting things in the air. In order to support that, we need the ground test infrastructure that gives us the information that we then roll into our flight tests. And we need to have that ground test infrastructure working hand in glove with the flight test infrastructure to make those systems possible. And that's really what HARF is all about. And that's why the partnership with industry, with Leidos, with Stratolaunch, that's why this is so important, that we can put something in a tunnel on the Purdue campus, understand it, learn the physics, hand it off to Josh and his folks so that Stratolaunch can put it on their Talon vehicle and actually fly it and get the real data. And we've done that, we'll have succeeded.
And one more thing. and it's often neglected in our thought process. It's not just the testing, it's building the modeling and simulation and validating the computational models that's going to allow Josh to cut the cycle time and the cost of getting to more aggressive vehicles. And it is the integration of all of that. And again, in the past, there's been a place to test in a wind tunnel, a place to test on a B-52. some people in another place running computational fluid dynamics. It's all in one place. It's government, industry, and academia. And that, again, it's a common theme that I want to keep coming back to. It's a whole series of skills that America has to relearn, and it is a combination of different elements of our society working together. That's what distinguishes us over the years.
So could I ask one more clarifying question?
Absolutely. And I'm sorry, who's speaking?
Sorry, Steve Trumbull with Aviation Week. I'm not neglecting the quiet wind tunnel at all, but it's just that the High Pulse has got this long story, and I'm trying to get all the details right. And if you could sort of fill in some of the gaps, I believe it started out at Langley and then moved to Gazel in the 80s. And it was very active for a long time, but it's been inactive for a period that I haven't been able to define. Can you confirm that basic structure, basically, and then how long has it been inactive since, and now you're reactivating it?
Yeah. So Steve, I'll have to get back to you with the exact dates because I honestly can't quote them off the top of my head. But you're exactly right. It was a NASA-derived facility operated at Gazel, Ronkonkoma. I can tell you a quick little anecdote, which is a couple of weeks ago, I was down at NASA Langley talking to some folks about, surprise, surprise, hypersonics. And one of them said, gosh, I wish we had that high pulse facility. And I smiled and said, it turns out you do. So I think, in terms of the on-again, off-again nature of the use of our wind tunnels, look, that reflects the on-again, off-again nature of hypersonics, which you've been reporting on for years. So you know it as well as I do, that we've seen this boom and bust cycle. And unfortunately, with the boom and bust cycle, you've seen a boom and bust cycle in funding ground tests and funding universities, by the way, and funding flight tests. So I think the fact that we've got High Pulse back up and running is a reflection that we as a nation are renewing that commitment to hypersonics. I know our industry partners can certainly speak to it. I'm sure Marty can speak to it, especially. Leidos' involvement in producing hypersonic systems is a remarkable story in and of itself. So this is Purdue stepping up to the plate. Steve and I can also tell you that right now in our major national facilities, we have a huge backlog. If you want to do a test on one of our major facilities today, you're looking at months and in some cases more than a year's delay before you can get into the test section. That's bad from many standpoints. Obviously, it slows down programs, but more importantly, it hurts the ability to do the development. If let's say you do a test and you see something interesting in your test and you want a couple more days test time at one of the major facilities, you might be out of luck because there's someone coming in right behind you. They haven't scheduled for you. Or let's say you go to the facility and your model breaks, or your instrumentation breaks, and you need an extra day. Well, once again, you can be out of luck. So bringing these facilities back online, especially refurbishing some of these facilities, I think is absolutely critical to our national posture in addressing our needs in hypersonics.
Great. Thank you, Steve. Any other follow-on questions?
I have one if you have a minute.
Sure.
This is Dave Bangert. I'm here in Lafayette. This is really a neophyte question and then a follow-up on that even. Number one, does the community feel any kind of effect in terms of being able to know that testing's happening or not? Or is it like at Zucro, you just don't know? And the other thing is, how does, just a really stupid question, how does Purdue make back this investment? Is that an industry or other people lining up and paying for that space or what? Thank you.
Well, so if we do things right, the community will not even know the testing has occurred. So, these are facilities which use a lot of energy and there's heated gas and lots of pressure differentials, but it's very, very well contained. It's a very, very safe facility. It's closely monitored. The HARF building is beautifully constructed. So no. Community won't know the testing is underway. In terms of making the money back, first I'm going to step back. It's not about making the money. All right? It's about fulfilling a national need, satisfying a national need, and that's a need for government, a need for industry. And that's not just the test capabilities, but as we said before, it's also the workforce, providing that workforce, that trained workforce to industry. The reality is, of course, we've got a number of partners. We've got industry partners. We've got significant government support. The high pulse tunnel that I was asked about a moment ago. I mean, that was a Northrop Grumman donation. So that was a huge investment from a company surplusing a facility. If we had built that facility from scratch, it would have been a much more challenging endeavor. But it's also doing funded work with the services, with the DoD, with NASA. And then taking on projects funded by industry, and in some cases there'll be joint projects where we go in with an industrial partner and together do development, do research.
Thank you, David. Any other follow-on questions?
Hi, this is Laura Heckman. I thought of a question I've asked before, but I am wondering, just kind of as far as specific technology, is there an area of hypersonics research that the U.S. needs to be focused on when we talk about this race and think about, being the fastest? And then is that area something this facility is going to help attack?
Yeah, so there are different facets to that question. And let me just talk about one. So electronics, for example. So that's one aspect of the hypersonics. Now, Purdue has a strong program around electronics, and in many cases, you have students that are, there's a cross-pollination between the semiconductor side as well as the hypersonics, the HARF testing facilities. So that's the intent, so that when they come out to industry, they have that cross-sectional understanding of the holistic view of a hypersonic vehicle and what that's made up of. I don't know if there's any other points you want to...
I could add to that. There are some monumental problems with hypersonics. I had one of the highlights of my career was when at NASA we started the X-43A program. And our team really worked this combination of things that I've been talking about. The testing on the ground, the computational fluid dynamics, the materials, and it is the integration. And they did, in a relatively short time, they got an air-breathing engine to Mach 9.68. In 2004, 2 decades ago, we had a huge gap because America gave up. So now let's address this specific question. Another thing in the HARF facility is advanced materials. When you're going to go at these kind of speeds, there's a tremendous amount of heating and friction. And one of the other areas that America has to start leading in to make a difference is in materials. There's polymers, there's ceramics, there's composites, and I'm sure your team is, both teams are working on it. So they have an advanced materials part of the HARF facility to deal with these monumental problems of how do I get things to go fast and not go self-destruct. So again, it's not any one thing, but it's the ability to synergize a lot of different things and train young people and have the advance of integration of the professors to system engineer things. And again, I love what you said, Josh. Your objective is to get tools to get it faster for less money, and you do it by doing these things. This is unique, and I don't see it in the literature for HARF, but having been through the facility and spending time with some of the professors there, this advanced materials is really key to America's future. And when you take a look at the magic that you could do with polymers and ceramics, it's going to change the whole directionality. So the other thing that I'm hoping for, and I come around and heckle Mark from time to time, is that we're going to lean forward and not be afraid of taking risk. in pushing the boundaries. And for too long in the field of hypersonics, America has been holding back and trying to hone the butter to a sharp edge. And we are in trouble because we did not lean forward and take risk. And this is what has to happen here. This is what has to happen across the country. We have threats.
So I like the question about where should we invest. Categorization I've found useful is that there are lots of different types of hypersonic systems. There are expendables, there are reusables, and then there's lots of different potential users for hypersonic systems. There's DoD applications and there are civil applications. And so if you think about those two sets of factors and two levels, that's a 2x2, four matrix of potential options there. And the answer is all of those. Now, the investments might be time phased a little bit. I think the expendables may be the more urgent thing. That's certainly what I worked on when I was in government before coming to Stratolaunch. But the reason I came to Stratolaunch is because the next thing after the expendables is the reusable systems to go after those leap ahead capabilities in the high endo atmosphere. And so our foreign competitors, whether they be Chinese missile developers or Chinese reusable launch system developers, understand they don't use the hypersonics terminology. They call the systems near space, and they view them as an asymmetric advantage, and they recognize that it's a warfighting domain. On the DoD side, it could be a domain for a commons for commercial activities on the civil side, and all of those things are important, and that diversity of capabilities and users is why this technology is so important. Thanks.
One other point I'd like to add to Josh's comments. So the testing, it's critical, the feedback loop, reducing that period of time, but the complexity of the supply chain has grown enormously. So with the close partnership between industry and the research labs, what's happening is that we have this cross-pollination where students that are interns that are coming out into industry, they're getting situational awareness of the challenges sometimes with supply chain, and they're taking that back to the research side to bring that knowledge base up so that on the front end, they're considering these different aspects that will be a challenge when you go downstream to a program of record. And the objective, obviously, is to mitigate the risk to programs and shorten that full supply chain cycle.
So I'm going to wax a bit philosophical, but I'm actually going to also address the question, right? Why is hypersonics such an exciting field? Well, I'll argue every true aerospace engineer wants to fly higher and fly faster, and that's what hypersonics is all about. But it's also intellectually challenging, because a hypersonic vehicle is perhaps the most fully integrated aerospace system that I know of. A properly designed hypersonic system is truly a flying engine. Sometimes I describe it as a flying self-propelled fuel tank, where parts of the airframe are actually actively involved in the propulsion. The front of the vehicle, the forebody, is the inlet to the engine. The back of the vehicle is the nozzle of the engine. Things that you do to the aerodynamic shape have a direct impact on your ability to propel the vehicle, on your ability to control the vehicle, with a degree of coupling that's greater than almost any other aerospace system that I can think of. So that's really exciting. It's an intellectual challenge, but that also points to the fact that in hypersonics, you kind of have to cover it all, which means you've got to have propulsion, you've got to have the materials, you've got to have the control. You have to understand how to build those into an integrated package. And sometimes in designing the ideal hypersonic system, you realize that you can't optimize every individual component. So if I just focus on the engine, I might wind up with an overall vehicle that doesn't function as well. I have to design it as a whole, which again, it's a challenge, but it's a fun challenge and it's an exciting challenge. One point I will make though, I think right now, if you assess the technologies and where we are, there are no technology showstoppers, right? We pretty much had to know, certainly for the expendables, and we built hypersonic systems, we've flown them, they work, we built air breathers, we built rocket boost glide systems. I'll tell you what I think is one of the biggest challenges that we really need to focus on, and that is affordability. And affordability is a function of how you manufacture it, right? How you design it. So even though you won't see anyone walking around with dollar signs in the HAR facility, but at the end of the day, when we're talking about manufacturing, using new materials, as Dan said, what are we really talking about? One, we're talking about enabling hypersonic flight in the first place, having the high temperature materials, the properties we need. But two, we're talking about materials that can be brought in at a price point such that Leidos can be producing hundreds or thousands of hypersonic systems, and that Stratolaunch can be testing once a week with different concepts and different configurations and different materials. That's how we'll know we're successful.
You know what? Let me put some numbers to that. And that is, if you take a look at how much hypersonic vehicles cost, expendables, they're probably a factor of 5 to 10. Too much. And then you ask yourself, how could America deal with a lot of threats that we have? It's interesting, America's hypersonic program is not nuclear tipped as compared to other peer nations. So the numbers that you have, numbers count. And the nation is not going to be able to have the leadership position it wants unless it's not just speed, it's not just distance, it's not just payload, but the nation has to, and Josh addressed it early on, the nation has to figure out how to get the unit cost down. It is the driving force because numbers count, and I'm worried. I don't think anybody's bad, but we cannot go on with the kind of costs we have. So bottom line cost to get more multiples will strengthen America's position relative to our peer nations. So it isn't socially acceptable to talk about it, but I believe that cost has to become one of the driving factors for the whole hypersonics program. It'll bring a level of honesty to the program.
Thank you. Thank you for the question. Do we have any other follow-ups? Okay. Hearing none, I'd like to thank everybody for participating today. We appreciate your time. I'd especially like to thank our panelists, Mark Lewis, Dan Golden, Marty Hunt, and Josh Stoltz, excuse me. Thank you so much for taking your time today. The press release about HARF will be, the official HARF opening will be released tomorrow along with a photo of the ribbon cutting. If anyone needs a press kit or has any follow-up questions or any other information, please feel free to email me at ecsosha@purdue.edu. Thanks again for your time today. We appreciate it, and have a good afternoon.